Hello, this is Robbie Mitchell here from Head in the Cloud Development. Today I'm going to show you how to use a SuiteQL Task to run a large query behind the scenes that'll save the results as a CSV file into the file cabinet and trigger a MapReduce script to process the file, all automatically. For reference, this video is being recorded in March 2024 on NetSuite version 2024.1. So if you're still interested, the specific goals of this video are demonstrating the use of the NTask module's SuiteQL Task functionality, trigger a MapReduce script to process the lines of the CSV file, demonstrate usage of Google's Geocoding API in a server-side SuiteScript, and walk through implementing and testing all this within NetSuite. This video is intended for NetSuite developers and administrators. You should have the administrator role in NetSuite to do everything I cover here. You should at least be familiar with JavaScript and basic web technologies here, and I assume that you've at least looked at the SuiteScript API before. Okay, so let's get started. Now, I'm not going to walk through downloading and installing all this here because I do that in my other videos. If you want to follow along exactly, you'll want to have WebStorm and Node.js installed. You can, of course, also do this in VS Code, which is totally free, if you're familiar with using the SDF plugin there. Where we'll start is downloading the code for this module from GitHub. So I'm just going to copy and paste this URL right into GitHub, and I'm just going to download the code directly using this link. So I've unzipped this file just in my Downloads folder, and I'm just going to open it directly here in WebStorm. So after you open it, the first thing you'll want to do is run npm install here to install the required node modules. If you're not familiar with files like package.json and tsconfig.json, then I recommend you watch some of my other tutorials where we walk through this in more detail. In this video, we're going to jump right into the code. But first, let's talk again about what our goal is here. I've just logged into my NetSuite demo account, and I'm going to show you a saved search here. So our goal here is to get all of our customers geocoded. If you're not familiar with the term, it means we want to have their latitude and longitude coordinates stored on the record. Having the coordinates enables us to do other cool things in NetSuite, like mapping them or calculating shipping distances. Geocoding an address is easy enough, and we'll get to that, but first let's talk about the problem of volume. Now obviously I don't have a ton of customers in my demo account, but you might have tens of thousands or even hundreds of thousands of customers in your account. With volumes that large, you can't really just easily export and import all those records. A MapReduce script in NetSuite is designed to handle large volumes though, so that's what we're going to use. However, one struggle with a MapReduce script is first determining or even finding the tens of thousands of customers that need to be updated. So today we're going to use a seldomly used SuiteScript module that'll provide a clean break in the functionality that we need to accomplish that. Let me show you this in the help. So in the help, if we go to the SuiteScript 2.x API reference and go into modules, let's look at the task module. And let me mention here that you can just as well do what we're going to do with a saved search task or a query task, but my favorite is a SuiteQL task, so that's what we're going to use today. So what we're going to do is start by creating a very simple scheduled script that'll trigger the SuiteQL task just to find the customers that need to be geocoded. And from there, it's going to store them as a CSV in the file cabinet and then trigger our MapReduce script. I think you'll be impressed with how easy this module is to use. So let's get into the code. Step one is to create the scheduled script that's going to trigger our SuiteQL task. This is our starting point, our mostly blank scheduled script that we'll use. Now, the most important thing I can teach you about NetSuite development is to do things iteratively. In other words, code a little bit, test often. Don't spend hours and hours writing code hoping that it's all going to work out at the end. Instead, test as you go, so if something does break, which it always will, you'll know exactly what it is. That being said, let's upload this just as it is, create our script in NetSuite, and run an initial test. So I've already set up my account authorization, so I can just use the upload file to account method here. So in NetSuite, I'm going to create my script. And then I'll deploy my script, save the deployment, and then we'll do save and execute just to run it and make sure that it's not broken yet. Okay, here's our execution log. So far so good. Now for the SuiteQL module, we need to use SuiteQL to find our customers. So let's use Tim Dietrich's wonderful SuiteQL tool, SuiteLit, here. If you're not familiar with this, it's a free bundle. Just search for a SuiteQL query tool in the bundle repository, and you can install it right now for free. So again, our goal is to find customers who need to be geocoded. In other words, what that means is that we want to find customers who have a valid address but do not have latitude and longitude coordinates. So let's start our select statement here, and we'll start it really simply. Let's select ID and entity ID from customer where what I want to say is where latitude is null and is inactive is false. So to help me with this, let me bring open that search I had a second ago. And any good NetSuite administrator or developer must know about the NetSuite Export Saved Search plugin. It's a Chrome module. This one here, I highly recommend it. What it lets you do is it gives you this Export as Script button on any saved search, and I can click on this to see the filters and columns involved. So what I want is to know what the ID is for this latitude field. So here it is. It's cust entity HITC maps latitude. These fields come from our Maps for NetSuite module, but you might as well just have your own latitude and longitude fields just as well. So back to our query, I'm going to say where latitude is not null and is inactive is false. So latitude is not empty and not inactive. And let's just run this. Nope, I got something wrong. No big surprise there. What is it? I think I have to say is not null. There we go. Sorry about that. I'm not quite a SQL expert yet. Okay, so we found 900 customers where actually what we need here is latitude is null because we want to find the customers where latitude is empty. Okay, here we go. We found 370 customers that are active but don't have a latitude. But how do we make sure they have a valid address? Well, unfortunately, joining in address details isn't super straightforward, but I'll show you anyway, and you'll learn about a useful tool here. So we're going to need a join, but before we do, when you're doing something more than just the simplest query, it's really helpful if you break the query into multiple lines for readability and understanding. So before I give you the answer for how to join this, let's look at what we have for customer in the setup records catalog here. So in the records catalog, let's go find customer. And let's click on the SuiteScript and REST Query API page here. And what we want to look for is the customer's default shipping address. That's the address we want to join on. So let's look at the Joins tab. And then look at this fourth row here. This is the default shipping address. This looks like what we want. And if we mouse over this eye icon here, it even gives us the join criteria that we need to use. And we can copy and paste that. And what we want to join is the entity address record. So back in our query, after the from, I'm going to say join entity address, and I'm going to say on, and then paste in what I got from the eye icon. So we're joining the entity address on customer's default shipping address being equal to the address's N key, which is basically its ID. And now back on the records catalog, if we drill in and look at this address and click on the Fields tab, we can see what fields we can pull from the address in the query. So look, we can get the address text here. So let's do that. I'm going to say select ID, entity ID, and address text. And if we run our query now, here we've got the address text coming in. Great. We obviously need this text to do the geocoding. This text is what we'll send to Google to get back the latitude and longitude coordinates. But what about this one here? ABNI Holdings just has an address of the United States. We can't really geocode at that level, or we shouldn't, because it won't be very useful. So let's add one more filter in here. So let's also say, and let's filter to say that address 1 needs to be not null. Just for consistency, I'll change this and to all caps as well. Okay, so now we got 18 customers. Hopefully you'll have a lot more, but this is fine for demonstration purposes. So now that we have our query, let's put it into code here. I'm going to copy and paste this, and in WebStorm, we're going to need the task module, so let's go ahead and import that. And now let's store our SuiteQL task in a variable. So task type should be task.tasktype.suiteql. Our query we have on the clipboard, and I'm going to use these slanty quotes so that I can keep it broken out over multiple lines, because I do think this is a lot more readable. And you can even use camel case, which I appreciate because it, again, helps with the readability. Now the other option we need to have here is the file path of where we want the CSV to be. Let me show you my file cabinet for just a sec. Super simple. I've got a customers to geocode folder right here in my root cabinet folder. So the way I use that is I just say customers to geocode, and then we need to give it a file name. So I'm just going to say customers.csv. Now we know that we're going to need to add an inbound dependency for our MapReduce script, but we don't have that yet, so let's just leave that commented out for the time being. Final step is to submit the task. So let's do this and upload and test. So I'll compile my script with the tsc command, and then just right-click and upload. And then on my script deployment, I'll do save and execute again. Okay, so it's complete. So with that, if I look in my file cabinet, I have a file that was just created, and let's take a look at it. So very simple, 3 columns, the customer internal ID, their entity ID, and their address text. Good enough to start with. So now let's start our MapReduce script that's going to geocode these customer addresses. So this is our starting point, our nearly blank MapReduce script here. So what we're going to do here is load the file in getInputData and then pass each customer row of it to the map function to be geocoded. But as always, we're going to test this iteratively, so let's create this script in NetSuite and test it as is. And do a new script for geocode customers. I'll save this and we'll deploy it. And I'm going to clear the concurrency limit so it can use both my queues. And I'll do save and execute. So there's my starting log. Okay, so it at least ran. So let's continue on. I think we didn't get the execution complete log because we didn't actually return anything. So to solve that, I'm just going to say return an empty array while we are starting this. But now that we've created our script, we have our script ID, and we can use this back in our find customers to geocode script. We can add this as our dependency now. So when we're adding a dependency, it's important to realize that we're not just adding an object with task type and the script ID, but we have to actually create a task again. So it's task.create, and then in here we can say task type is task.tasktype.MapReduce, and the script ID is that. So now if we compile and upload both these files, then if I run my scheduled script again, this should actually trigger our MapReduce script now. So it says it's complete, and let's see if our MapReduce script triggered. It did. Yeah, it ran at 51 minutes after, so that's great. And there's our execution complete log. So far so good. Now let's dive back into our MapReduce script and really get it to be doing something. Step one is we need to load the file. So let's import the file module. And now, depending on your implementation, you might need to do something smarter here, like using a script parameter to get the file ID, or maybe do a search to find it. But in our scenario here, we know exactly which file it is that we want to load, so I'm just going to code it by the internal ID. So here I'm going to say const csv file equals file.load, paste in the internal ID. And now let's think, what does this CSV file look like? Well, remember, it has three columns: the internal ID, the entity ID, and the address text. So to parse that, let's set up an array of objects called customer addresses. And I'll define it like this. So I'm not putting the entity ID here because we don't actually need that. That's really just for our human visual understanding of which customer it is. All we really need is the customer internal ID and the address text. So once we have the CSV file loaded, we could probably just parse it by new lines and parse the columns by comma. But seeing as how you might have thousands and thousands of lines, it's probably a better idea to use NetSuite's built-in file line iterator method. So all we have to do is say csv file.lines.iterator parentheses .each, and the object here is a line that just has a value string on it. So this iterator is meant to handle very large CSV files, and it'll break them down to give us the text value of each line here. And very importantly, let's remember to return true after we process each line to tell it to go on to process the next line. Now for each line here, let's break out the CSV column values by splitting the line by commas. And I'll just put a comment here so we remember what the columns are. And so with that, we know that the customer ID is column 0. And the address comes from column index 2. Okay. Once we get these values, let's go ahead and log them so we know what this line looks like that we're processing. And one thing to keep in mind here, we don't actually want to process the header row of the CSV. On that note, we wouldn't want to process any line where the customer ID we find isn't a number. So let's add a line of code to skip those here. We use the notAnumber method, checking the customer ID. So again, this says to skip any line where the customer ID isn't a number. Such as the header row. Otherwise, we will push our customer ID and address into our customer addresses array. And that's what we want to return at the end of our function here. Now before we move on and try to actually do anything in map, let's upload and test this and see how things are looking. So to be consistent, I'm going to try to always trigger this from my scheduled script. Okay, it says it's done, so then let's check the MapReduce script. Alright, so it definitely ran. Looks like it ran on about 18 lines here. But now look, we actually have a bit of a problem here. These addresses don't look like what I have in my CSV file. Or at least, not all of it. Look, Acme Systems Incorporated here only comes through as Acme Incorporated. I wonder if that's because this address is broken out over several lines. One thing we can do is actually open this CSV file in a text editor to see things from a different perspective. Now when we do this, it looks all messed up. We can see Acme Systems Incorporated, but then it looks like the address here is broken out over 3 lines before we get to the next customer. That's bad for CSV processing here. This really isn't going to work well with NetSuite's CSV line iterator either. So what can we do about it? Well, the best thing to do is probably to address this right in our query so that we can avoid getting these line breaks in the first place. Let's take another look at our query here. Now, in this SuiteLit, as great as a tool it is, we don't really see the line breaks in the results here, so we're a little bit deceived. I'm going to show you an alternative method to running this query in your browser. Anywhere in NetSuite, if you pop open your browser console, we can paste in a couple of lines here to basically enable the SuiteQL script module. So first it's to require n/query, and then var query equals require n/query, again, without the square braces. Once you've done that, you can copy and paste the query SuiteScript method to run any query. So it looks like this without any query. And then if we just copy and paste this query into our quotes here, press enter, here are the same 18 rows in JSON. And with this, we can see the new lines that are messing up our formatting here. So how do we get rid of them? Well, a quick Google search will lead you to find that we can use the replace method right in our select line here. The new line character code is character 10. So the way we do that is we say, let me get to a new line here. I just press up on my keyboard to get to the last command again. And now right in my query, around the address text, I'm going to say replace, parenthesis, first parameter is the column that we're replacing, then comma, chr10, and the third parameter is what we want to replace it with, which is just a space. So we're saying replace any character 10s in the address text with a space. Let's run that and see if it looks any better. Yeah, so now we get Acme Incorporated, 379, Visalia Circle, Honolulu, Hawaii, all on a single line. That should help with our CSV situation. However, the only thing is it comes through as expression 1 rather than as our address text. So to fix that, let's just say as address in our query. Okay, that looks better. So let's copy and paste this into WebStorm. I'm just going to copy and paste this little bit here. Replace that. And let's upload and test this. I'll run my scheduled script again here. Says it's done. And if we check our MapReduce script, we now have the whole addresses coming through. So that is great. That should work a whole lot better. So now that we have the address text correct, let's look at how to geocode the address to get the latitude and longitude. First, in our map method, let's parse our context value into customer ID and address so we can work with it. Now, before we can geocode, we need to have an API key for Google's Geocoder API. Let me show you how to do that. Let's go to the Google Cloud Console. Now, if you don't have a project set up, you can create a project. I'm just in my SuiteScript demo project here. I've come to APIs and Services. You'll want to make sure that the Geocoder API is enabled. I'm going to go to Create Credentials, and we need to create a credential here. It's just an API key. I'm going to copy that. Click Close. And to make it a bit more secure, we can click on this API key and actually restrict it to just the Geocoding API. Don't worry, I'll make sure to delete this API key after the video here. So now that we have an API key, you can copy and paste that into WebStorm. And then we need the HTTPS module. So we'll call the geocoder here. The URL is maps.googleapis.com/maps/api/geocode/json. And then there's just a couple of parameters. The first one is the address that we want to geocode. And the second one is our API key. And that's it. So let's log what our response comes back as. I always like to include the context.key in my map logs in case there are multiple things happening at the same time. We'll say response for input. We'll include a timestamp because sometimes it's good to know that these things are happening in a timely manner. Okay, now before we do anything with this response, this is a good time to test so that we can see what the response actually looks like in case we're new to this sort of thing. I'm going to run my script again. So at this point, it should actually be sending all of the addresses to Google and getting back a geocoding response for each one. So look, that is exactly what's happening. So some of them came back with 0 results, which tells me that this is just some test made-up address that probably doesn't exist on the planet Earth. But a good number of them should come back as perfectly valid addresses. Now let's just pick a random one, and what we're going to do is, let's copy and paste this response into a JSON beautifier just so we can see what it really looks like in a cleaner manner than this. So if we beautify this response, we see that this is kind of what it looks like. It's an array of results. Here's our address components, some information that we don't care too much about here. But here is our geometry section, here's our location, and here's our latitude longitude coordinates. So that's what we want to try to extract. So with that, let's try to parse our responses now in our code. And let's define an interface with the attributes that we care about. An interface really just defines the format of the data. And again, there's a lot more than what we're actually going to put here. But we just need to know how to get the latitude longitude out of it. So for that, we saw that there's a results array. It's an array of objects, and each object has a geometry section, and in the geometry there's a location, and in that location there's a lat and a long number. So this is kind of the path to what we care about here: results, geometry, location, lat, and long. That's what this means. And we also care about the overall status, because if it's not a valid address, we don't want to try to parse it. So with this interface, we can say const parsed response equals json.parse Google response.body as I geocode response. And then here we can say if parsed response.status equals OK, then we know it's a valid address that we want to go ahead and try to parse. So then the way we get the coordinates is we say const coordinates equals parsed response dot results, the first result element, dot geometry dot location. And then finally, we want to update the customer record with this data. So for that, we need the record module. So we'll say record.submit fields, type is customer, ID is customer ID, values. Now here again we need the latitude, longitude field IDs, which I can get from my search. So the latitude is here. And the longitude is there. Now it's always a good idea to log when you've updated a record, so let's do log.audit. Again, we'll include our map context. Customer updated. Customer got customer ID with lat coordinates.lat and long coordinates.lng. Again, we'll include a timestamp. All right, let's do a final test and see if it works. Run my scheduled script one last time. I'll check my MapReduce script. So there's our get input data running. Map. So map 1. Map is running. Okay, the last log was that customer ID 1009 was updated. So in theory, if I run my query again, they should all have addresses now. Well, I got 4, so these must be the ones that have a very invalid address. Yeah, I think that's the case. The rest of them do correctly have latitude and longitude. And if I just look at it from my saved search again, we should see those values here now. Yeah. So look, only the 4 with invalid addresses don't have them. So that makes sense. So great, now all our customers who have a valid address are geocoded. And that concludes our Suite scripting tutorial for today. I hope you've enjoyed this video. Feel free to get in touch if you have any questions. Otherwise, we'll see you at Suite World. Thank you for watching.